it's always nice to get out of the valley, and it's certainly cooler down here than it is in the valley.
Even though it is a warm day here.
Yeah, it's a little bit warm. I know Vivo brought something to show to you guys. Did anybody else bring something that they wanted to show?
Kinda.
Okay. Well, let's let Vivo go over what he's been working on the past couple of months, and then we'll go on to you. Go ahead, Bill.
Past few weeks, actually.
Okay, past few weeks.
Yeah, don't call his projects in terms of months.
Well, maybe one. And I plan on building a little Stirling engine, one of the Miser Stirling. And I got a little bag full of 080 taps. And I took a look at those and was like, man, I'm going to be breaking a bunch of those fuckers. And so I built a little hand tapper that uses an ER11 collet. And then proceeded to try drilling holes using the big old Craftsman drill press. Hey, plastic wasn't a problem, but when I got to the aluminum, I shattered that son of a bitch.
Yeah, the aluminum, the little adapter still didn't work, not enough RPM.
Not enough feel. It was like trying to swat flies with a hammer.
Right.
But so I decided to build a small drill press. The Dremel stuff is garbage.
Oh yeah.
And these plans actually came from the guy that did the Miser Stirling, Jerry Howell.
Yep.
This is a scaled up version of his micro drill press. It's probably about 50% bigger than the original.
Jerry, moved your left just a hair.
His design, the quill
that's
shaft
all right.
is a 1/4-inch shaft running in ball bearings, and then I guess a Jacob's tape for 0.5 or something like that, and then this tiny little keyless chuck. The keyless chucks, casual looking around, they were $60-70 if you could find them. And I decided I like the ER collets a lot. Thanks, Marty.
Yeah,
And,
that's brilliant.
it's
Absolutely brilliant.
ER collet extension. It's 8mm shaft. So I just kind of upscaled stuff. His quill shaft was 5/8 tool steel, so it's just a matter of I had to go to.
Or his family, he's passed away, but yeah, it's a good place to look if you need a project.
Holes goes through here. Each of these lines does 5 turns around the shaft, and then ties up on this rod at the bottom, which you can rotate and clamp to tension it.
Simplicity.
The good part is it's zero backlash.
Oh yeah.
A lot easier to make. The only downside to it is, I'll hand it around. This is the fishing line,
Oh yeah.
and it's waxed.
Yeah.
So the more you use it, the less it works. And I've got the tension up enough that it's probably going to part ways. Brian Campanella and I were talking this morning.
I got a piece of
About-
Dacron I'll give you.
Well, he's got this stuff that's fiberglass on the inside and something else. Grip. It's a pretty clever design, really. Like I said, I upscaled it by about. I made the first quill assembly according to his plans, other than with the change in bearings, and it wound up being too short. I would have had 3/8 to maybe a 1/2 inch of travel. So I remade the quill. Timing belt. And you can buy pulley stock. You can buy like 6-inch sticks of these gears, and just, it's not cord. You just drill and tap and cut it to size. The knobs are 3.5 to 12 volts. It's a brushed motor.
You can use them for all sorts of things.
And I just adapted that. And is making a smaller pulley for here, or making a bigger pulley on the motor is going to require redoing the motor stand, which is fairly easily adaptable. I can probably conjure up something for that.
So you want a little more RPM then?
I think Q's kind of pushing it pretty
So
hard.
I'd run an engraving tool real easy.
I would assume.
When it-
I would assume.
Oh yeah, that'd be plenty of power for that.
Yeah.
Yeah.
But it's
How does the magnetic vise work?
What?
How does your magnetic vise work?
Feed 6 volts into it. Yeah,
Right, but how does
Well,
it
you're
get
gonna bore a hole in the base. You're gonna bore a hole in the base and bring it so that the surface is level there.
How does it clamp the part though?
Magnetic.
Well, if it's steel, it'll stick to the
Oh,
magnet.
it's steel.
Yeah.
So that wouldn't work on aluminum or something.
I've been up here about, I'd say 10 years full-time, maybe 8 years full-time. I was up here part-time for a couple of years. The last few years I was working. So I primarily am focusing on blacksmithing. So that's one of the things I've built recently up there on the screen there, that wood cart. It's for my son-in-law. He's got a cabin up in Duck Creek. And I built that so he could load it up with wood and wheel it in and park it by his big fireplace. So as far as the shop, most of the stuff's pretty standard stuff. Every time I go to a shop, and I go to a lot of blacksmith shops. Salt Lake City 2 weeks ago for the big 4-day blacksmith conference I have every couple of years. Havana, the North American Blacksmith Association puts on a conference every couple of years. It's really kind of a big deal. It brings in people from all over the world to do demos. So anyway, yeah, we can walk around. I'll point out a few odds and ends here. This is something I ran into. I always had trouble. I have no trouble starting my weld, but once the thing starts going, I lose track of the joint. So I'm on it, and then by the time I get to the end, I'm off it. Because you can't see. You can't see the joint. So, and I tried putting these lights up here, and they mess up my helmet, turning on and off and everything. So I ran into these things out at the salvage yard in Prescott here about a year ago. There's 2 of them. I bought them both. I had a tough time convincing the guy to sell them to me because they were with the dentist chair. But anyway, I talked him into it. So and I turned this thing on,
Brilliant.
It gives me a mouth-sized, for some reason, it gives me a mouth-sized bottom light. I get this baby on my welding joint, I can see good.
Really?
Yeah,
Oh, yeah.
real good. Got 2 brightnesses on it.
Yeah, that's
Kind of a small saw, and actually it has a liquid circulating pump, which I used for a long time, up until about 3 months ago. It gets sticky, you can't get the stuff out of it, stinks, it's horrible. So I cleaned it all up and I thought, all right, I'm not gonna use that pump, I'm not gonna use any liquid in this thing anymore, I'm just gonna buy blades more often, and I'm gonna do all my rough cutting on this thing, putting accurate cuts. So I went back to that thing for my main saw, and I use this for when I have to do more precision stuff. Which blacksmith will. You sold this to me, absolutely. Matter of fact, that's the first time I ever met Marty,
Yeah, that's right.
and that's when I found out about this group.
Yeah.
When was that, 10, 12 years ago?
That was a long time ago.
Yeah, yeah. And I use it I use it quite often, actually. I use it more than I do the mill.
It's a freaking beautiful machine.
Earl and I with 3 tweezers and a magnifying glass and a flashlight. It's pretty funny.
This is your remote controlling the VFD.
That's from 14?
3 a.m. See, that gives me the capability of having more control than I had before, so it's really working pretty nice now. I'm also doing some experimenting on the valving here.
And you can be
The
on,
bottom valving.
best part is you can be old and still blacksmith.
Doug, is it pneumatically actuated? How does the thing work?
There's a compressor in the back, and
Oh,
then there's a ram in the front.
right.
And there's a hose, basically when the piston goes up in the back, it blows air through a hose on the top and it runs the ram down. And when the piston comes down, it blows air out the bottom hose, brings the ram up. So
So it's alternating.
So it's like this.
Oh.
It,
That's
That thing
why they
looks-
basically all work, all these self-contained pneumatic.
You gotta wind this 5 times around the shaft, and trust me, this stuff is fun, a lot of fills station on.
It's springy.
Yeah,
It doesn't want to make turns.
as it was with this stuff, what you see is very string-like.
They
You
check
take a turn around, you had to hold it
One end,
to make my own
Yeah,
set of
look at
jaws,
this
and I
guy.
think the amount of time
Hi. You
involved
live,
precision,
Beach area?
has been better with theirs.
Stuff.
There's nothing mysterious about it at all.
I got the front apart right now, I'm waiting for some screws, and I needed to. It's kinda handy.
That's a hell of a screw it's got on it.
I mean, you can see equipment that, some of you guys have in your shops today might be photographed. What I'd like is while we're eating, somebody walk up and tell me that we got an interesting piece of equipment they don't need, small tooling or something they want to trade for.
So the retraction pressure helps you control speed of retraction, or?
The speed of retraction is fixed, except I can change it in the controller.
Okay.
I can punch in a different speed for that. I've got a discrete that goes in there, and whenever this thing is in the retraction mode, it tells that thing to go to a constant speed, which I can fix with the constant.
This was the prop from the first Terminator.
Do you use the retraction to do work?
So, well, the reason I need the retraction is because one of the things that I'm going to do with this thing is I'm going to slit and drift metal. It's hot, right? And you take a slitting punch, and then as the punch goes up, it changes from a slitting punch to a round, and then sometimes to a square.
Right.
So you end up with a square hole. And when you do that, you have to have stripper bars on the top. So when you retract it, it holds the material and you pull up. So I just wanted to be able to have a slow retraction speed, and I wanted to be able to have adjustable. And this was the original ram, so I used the original ram for the downstroke, but it was a spring return. So I put those 2 retraction cylinders in there.
So they only retract.
These VFDs, they've got a couple modes. And normally, what I was thinking of VFD, basically you control the frequency, so you control the speed of the motor, right? And that's basically what they do, but if you put them in there, there's a mode called a scalar mode. Are you guys familiar with it? So scalar mode versus vector mode. Scalar mode, basically, you can, if you take a motor and you just run it on power without any VFD, and you start loading up the shaft, you load it down and load it down and load it down, right? It still maintains the speed. It'll change a little because of the slick, but it slowly puts more of a load on the motor. And then at some point, the motor's going to stall.
It's gonna be so
And all the torque is basically going to go away, and the motor's going to be pulling a lot of current, and it'll trip the breaker, basically, usually, that's what happens on. Some motors are sized so that they don't stall. So you put a VFD on there, and you crank it down.
Hey, Jerry, Larry, let's let him talk.
You put a VFD on there, and you slow it down to, let's say you slow it down to 40 hertz. So it's running at 40 hertz instead of 60. Now you start loading down the motor. You load down the motor, if the motor puts out 10 horsepower at 60 hertz, up, down, 10 horsepower max, let's say as an example, it'll stall at about a little bit over 10 horsepower. You take a VFD and you run it down to 30 hertz, and you start loading down the motor, it's going to stall. You only retract it over
Oh, yeah, that's
300.
because horsepower is torque times speed. So at 30 hertz, half the speed, the most horsepower you can get out of it is half the max, right? Now, they got these modes in a VFD that are called vector modes. And what they do basically is you put the VFD on there and you run the motor at 60 hertz. Say it's a 10 horse motor again. You run at 60 hertz. You start loading the motor down. You put more and more and more and more and more of a load. You get up to 10 horsepower, which is the max, right? You add some more. The VFD backs the voltage down and backs the speed down and holds the torque. So you can put more and more and more speed. The motor is going to slow down, keep slowing down, keep slowing down. Torque's going to hold the entire time at the max torque because the VFD is controlling the current. Slow it all the way down to stall, all the way down to stop, 0 speed. It'll sit there and hold the torque. Right? So that is handy. That's the way I'm operating this thing.
Once you start overwhelming the motor and it starts getting near its stall point, once you start backing the frequency.
You can find 480 volt VFDs pretty cheap because nobody wants them. Nobody uses them. They take them out of industrial buildings from process control, they take them out of air conditioning. They end up in places like Apache Reclamation where I bought this one. They're up on eBay. eBay tends to want a little more money for them, but because of the fact they're 480 volt VFDs, you can buy them pretty cheap. Secondly, if you have a 480 volt VFD, like I was just talking about, you can run a 240 volt motor with it. You don't have to have you don't have to have a low voltage 220 VFD. You can use a 480 volt VFD. The whole trick is you got to use that transformer. I got that transformer behind the shop to get your 480 volts. And so if you want to buy old machinery that's got 480 volt motors, which a lot of people kind of like old machinery, this setup here will let you run machinery that's got 480 volt motors on it, as long as you find a fairly high horsepower VFD.
Right.
How much do transformers cost?
That transformer, I bought that transformer I'm using for $100 out of a founding factory down at Casa Grande. They're advertised quite often in Craigslist, these line transformers, different KWs. I think mine's like a 1500 KW I have out there.
So I designed this for a Mitsubishi 4G63 car engine. They put in the 90 series Mitsubishi cars. And it's a rotary valve cylinder head design. So instead of having poppet valves, it has a spherical surface valve, a lot like a ball valve that rotates. And one for intake, one for exhaust. Pretty simple, just a different way of doing things. And this is the latest product. This is latest progress. This is casting number 8. Still got some problems to work out, but I'm getting there. I think it'll be usable. And then this is the first casting for the valve cover. And I'll need to do it again because it's got a pretty big defect right there. But
Looks pretty good to me.
It's looking at the head bolts, a lot better.
yeah, they came in. I didn't bring them, but they came in. I was having trouble with the finding head bolts, so for the stock head, the head bolts are too long for this head design, and it takes too much to redesign. So you can't just buy off-the-shelf bolts.
Washers.
Well, so the head
Well, you gotta
bolts,
make your own, you mean?
the head bolts are right here, so they can't be any longer. And the stock head bolts, they're torque to yield, so the shank is narrow, and so you can't put more threads on them. And there's not enough threads if I cut it off. And it's a M11 by 1.25, which nobody makes.
No, that's it.
It doesn't exist.
Non-standard.
So
150, you'd be okay.
after searching and talking to people and asking some questions on forums, somebody suggested a Nissan something car might have some that work. So I dug into that. Didn't really get any good leads. It was actually a model that I don't think sold in North America, and so I couldn't even find them in local auto parts stores to go check them out. But it did lead me into finding an 03 Xterra has the same thread head bolt, and they're super long, but the threads go all the way up, so I can cut them off. So if you need M11 by 1.25 bolts, check out head bolts for a Nissan Xterra 03 model.
Those aren't torque to yield though, are they? They can't be.
I don't think they would be, yeah. So I might have to play around with torque settings.
So my question to you is, how do you time the ports and how are you gonna seal
You
this?
build the whole engine?
So first question is timing. So there's another piece I didn't bring. Basically the stock head is overhead valve motor, so the cams sit right up here. And I built it all so it'd be a bolt-on replacement. So the stock timing gear belt pulleys sit up here, and they're in an assembly that's geared to turn this right here. And so it'll rotate that shaft, and it's timed just like a cam is timed. And the second question is the sealing, and that we'll see how it goes.
Still working on that.
So the first plan, I think the best thing would be a super hard steel alloy, and maybe like a super high-tech coating, one of these PVD coatings like they put on tooling cutters, like titanium nitride, something like that, or diamond-like carbon.
Mazda rotary engine, how do
Yeah,
they do
wipers
it?
in there.
Yeah, and they're oiled though, but it's some type of carbon steel.
Okay,
but they're oiled.
Make some V-dyes.
This is gonna have no lubrication in it, is the plan.
We just can use it for-
The oil comes up through, I think, this head bolt, and I'm basically just gonna find out what size of orifice I need to keep oil pressure everywhere else in the galleys, what it needs to be, and just dump it right back in the block. So there'll actually be no oil in the head. But my first plan of things that I can actually do without having to outsource work, which is probably gonna work for the intake valve, I think, but not the exhaust. And this is just a cast 356 alloy. And then my plan is a hard coat to anodize it. And then for the seal surface, you can see I made one of them down there. This has O-rings and it's got a spring, so it keeps the, so I don't have to worry about tolerances changing. But my plan is to put, I've got a metallized graphite bushing material I found that this company makes. And it's made for severe duty applications where you can't have external lubrications or oils. And it's some kind of formulation of like a sintered graphite and like bronzes, I think. And I'm gonna machine a ring and sit it in there and see how well it works. I have a feeling, I'm pretty confident it'll run because I've built a 1-cylinder head prototype and I just used 6061 and bearing bronze and no oil or nothing. And it started, you know, proof of concept, it started. I'm pretty sure that the exhaust valve might melt. Hard coat anodize is kind of open and just absorb it.
Yeah, but the implication is that for lower launches, they can bring
Just have some back there.
I'm gonna go to that, first train to Prescott.
Right on the counter.